And then, of course, privacy. They can potentially just regurgitate data from the training set. And then ethics, concerns over misinformation, job automation, and misuse. So I also mentioned generative adversarial networks, or GANs. So a generative adversarial network is a type of neural network architecture where two networks, a generator and a discriminator, compete against each other in a game theoretic type of setup. So how does a generative adversarial network function? The generator, so you basically have two sides, right? The generator tries to create fake data like images that look real. And then you have a discriminator. And the discriminator tries to tell if the input data is real from the data set or fake from the generator. And over time, the generator gets better and better at fooling the discriminator, which actually results in highly realistic data. Because as the generator gets better, so does the discriminator. So an analogy would be like a counterfeiter versus a detective. So the counterfeiter makes better fake money. The detective has to get better at spotting the fakes, and they improve each other through the competition. So if you ever saw the movie Catch Me If You Can, about one of the most famous con artists of all time, Frank Abagnale, he got great at making checks as a teenager, faking checks. And the FBI tried to track him down, but every time that they thought he was one place, or based on the checks that were being cashed, he'd actually be someplace else. So it's the same thing here. So as the counterfeiter gets better, the detective gets better. And eventually, if you saw the movie, he got caught. So this is used for generating realistic images, deep fakes, and data augmentation. The challenges with GANs is they're hard to train. They can become unstable, or they have what's known as a mode collapse. The generator produces limited variety. We also talked about, or I mentioned on the last slide, variational autoencoders. So what are they? So variational autoencoder is designed not just to compress and reconstruct data, but also to generate new data that resembles training data. And how they work is the data is originally passed through an encoder, and that encoder compresses the input data into a distribution of latent variables, usually a Gaussian, right, which is the normal bell curve, right? Then there's a decoder that reconstructs that data from these latent variables. And during the training, the model learns a meaningful latent space where similar inputs map to nearby points.